Okay, we're ready to begin section 1.4, our second section. This section will be very similar to the last section in many aspects. We're still solving for x or y or whatever variable is present, but now we'll be solving inequalities. Inequalities will have a greater or less than or equal to sign, a less than sign, a greater than or equal to sign, or a greater than symbol. So that's the distinguishing factor between inequalities and equalities. Equalities will have an equal sign. On this section and on your test, I ask you to do 3 different things. I ask you to first solve it, then graph it, and then write the answer in interval notation. So this you will have to do on Alex, and you may have to do in other classes, but I usually don't ask for set builder notation. It's just a pretty way to write the answer. So let's start with this first one. When it looks like an L, that's read less than, and there's a little line underneath. So this is x is less than or equal to 3. So when it's equal to, we use a bracket. When there's no equal sign, we use a parenthesis. So you may remember in high school when there was an equal sign, you used a solid dot, and when there was no equal sign, an open dot. Well, in college, they switched that notation, so now it's a bracket for an equal sign and a parenthesis for no equal sign. So less than means shade left. So we put a bracket at 3 and we shade left, and that is the graph for this inequality. So on a number line at the far left end is negative infinity. So we have positive infinity at the right end. At the left end is negative infinity. So when we go to write interval notation, we can never be equal to infinity. It's always beyond our grasp. I always think of Buzz Lightyear, infinity and beyond. So we can't ever be equal to infinity or negative infinity. So notice they will always get a parenthesis. Every time you write infinity, it's a parenthesis. So when we go to write interval notation, we have to keep the answer in the same order. So negative infinity first, comma, the other endpoint is 3. As I said, infinities always get a parenthesis, and the equal sign tells us to put a bracket at 3. So those are the 3 things you have to do on the test. Solve the inequality, make a graph of it, and then write the interval notation. So set builder is just putting set symbols in and saying x such that, and then you just insert the answer there. So it's just a pretty way to write the answer. So for all x, such that, and then we insert the answer, and it's called set builder notation, so it does need to have set symbols. X is less than 3 will almost be identical to the one above, except because there's no equal sign, we use a parenthesis rather than a bracket. So our interval notation will be negative infinity, comma, 3, keeping it in the same order, and order does matter. Infinities always get a parenthesis, and because there's no equal sign, the 3 will get a parenthesis. And then the set builder, set symbol for all x such that, and then you just take the answer and put it in. X is greater than or equal to 3, so when it doesn't look like an L, these look like an L, they're less than. When it's the other way, it's read greater than or equal to 3. So that means greater than 3 are going to be all the values to the right of 3. Because there's an equal sign, we put a bracket at 3. This time it's pointing to the right end of the number line, so that's where our infinity is. So when we go to write our interval notation, it's bracket 3, comma, infinity, and like I said, infinities always get a parenthesis. And then our set builder for all x such that, and you just take the answer and plug it in. And then end the set builder. And then greater than 3, just like the one above, except it uses a parenthesis because there's no equal sign. And again, infinity is here, so it's 3, comma, infinity, both with parentheses, because infinities always get parentheses, and no equal sign. And like I said, order matters here, so it has to be the same order as the number line. So you graph it first, and then you bring that order over. Graph it first, bring the order over, and so on. So solving inequalities, like I said earlier, is exactly like solving linear equations, except for one difference. On the last step, or it could be the first step, but usually it's the last step, when you divide by a negative quantity. If it's the first step, you might be multiplying by a negative quantity, like to get rid of a fraction, but usually it's the last step. When you divide by a negative, you have to reverse the direction of the inequality. That's the only difference between solving equations and solving inequalities, is you have to always look and see on your last step, am I dividing by a negative? If I am, I have to flip the symbol. So let's see how this looks on paper. So we have 4x plus 3 is less than or equal to, because it looks like an L, so less than or equal to negative 6. So just as we did with equations, we want all of our x's on the left, anything without an x on the right. So we need to subtract 3 to move this, and remember that's called a constant because it doesn't have a letter or a variable. And whatever we do to the left side, we do the exact same thing to the right side. So this cancels, that was our whole purpose, and we get 4x is less than or equal to negative 9. When the signs are the same, we add and keep the sign. So this is where I have to pay attention. Am I going to be dividing by a negative? See the word by? That means this number would have to be negative, and it's not. I'm dividing by positive 4. So this is times 4, so do the opposite, divide. So since I'm dividing by a positive, I don't flip the symbol. And forgetting to flip the symbol is a big deal. That means you're going to shade wrong when you go to graph it. But we're dividing by a positive, so we don't flip it. And we get negative 9/4. Or perhaps I can show you how to do this. I know most of you can do it in your head. But if you had a big number that you couldn't do or didn't want to take the time, you could go negative 9 fraction bar 4, and it will change it into a mixed number for you. So negative 2 1/4. So you can do either one of those. You could even change it to a decimal, but like I said, we usually stay away from decimals because if the calculator screen gets filled up, that means you can't use a decimal. This one it would be okay, but just stay away from decimals unless you're doing like money problem. So I can put either one of these up there. And if you're doing a test on Alex, just read the directions and see which form they want. If they don't specify, then you can put either one. So most students would rather graph this, so I'll do this one. X is less than or equal to negative 2 1/4. So the first thing I notice is, oh, there's an equal sign here. That means I need a bracket. Second thing I notice is this looks like an L. That means it's less than, so it's going to be a bracket, and it's going to be shaded left for less than. And then you label your endpoint, which is negative 2 1/4. So everything to the left of negative 2 1/4, because it says less than left. 2 L's, less than left. And then I label what's down here. This is the other endpoint, negative infinity. Then I drop my 2 endpoints in the same order, negative infinity first, negative 2 1/4 second, and then I decide the shapes. So infinities, like we said above, always get a parenthesis, but negative 2 1/4, because of the equal sign, and we put it there, gets the bracket. So that would be the interval notation of the answer. That would be the graphic solution, and this is the algebra solution. So they all are portraying the same answer, they're just different modes. Algebraic solution, graphic solution, interval notation. So x is less than or equal to -2 1/4, which is shade left. So that's not bad, right? Okay, let's try another one. And if you want, go ahead and shut off the video and try this one before I do it. This is very similar to number 1, and see if you got the hang of these easy ones, and then we'll move on to a little bit harder ones in the next section. Okay, so let's write our equation, or inequality. -3x minus 1 is less than -4. So I see all my x's are already on the left, so that means I need to move my constants to the right. So do the opposite, add 1, add 1. So -3x is less than -4 plus 1, -3. Okay, this is a step where I have to be alert. This is times -3, so the opposite is divide by -3. So when your number down here is a negative, or whatever in front of the x is a negative, that tells you, ooh, I have to flip the symbol, because this says if I divide by a negative, reverse the inequality. So this turns into -3 divided by -3 is 1, so 1x, or just x. Because I divided by a negative, I have to reverse the inequality, so now it's going to turn into greater than, and you can see how you would miss it if you forgot that, because you would think the shading's to the left, when now we can see it's actually going to be to the right. 2 negatives equal a positive, and 3 divided by 3 is 1. So our solution is x is greater than 1. So now we have to graph. So greater than goes to the right, and 1. So it would look like this. And we always shade in the arrow to show that it goes on forever. So since we're on the right end of the number line, this is going to be positive infinity. Can't write negative there. You have to be careful with your signs. Positives on the right, negatives on the left. And then our interval notation. 1 is first, infinity second. We have to keep them in the same order. 1 has a parenthesis because this problem has no equal sign, and infinity always has a parenthesis. So everything counts. You mess up the order, you lose your points. You put a bracket instead of a parenthesis, you lose your points. So you have to be really careful on these steps that you follow your symbol. And so we shade using the very last symbol, not the symbol from the original problem. So we divide it by a negative, and according to our box, that means flip the symbol. So let's practice because Alex, like I said, is going to ask you for the set builder. So let's just do one with set builder just so you can see it in action. So the set builder notation, you use the variable that's in the problem, x. For all x, this is read such that, and then you put the answer in. X must be greater than 1. So if Alex asks you for the set builder notation, that's what that would look like. Okay, I'm going to end the video because we have less than a minute left, and we'll start on page 2 on the next video.